Thank you so much for having me. I hope that this session is useful. And as Kanchka said, this is the first of two sessions. And the main topics that we're going to be discussing today is what is life cycle assessment and defining the main words and topics that we need to understand before we start a life cycle assessment, how to go about developing and arriving to the results in a life cycle assessment, and what are the different parts, how do we process the data, what impacts do we want to focus on, why having this thought process, which is similar to other forms of research, but there's some parts that are a bit confusing when you first start out. Then we'll briefly discuss over some different types of software, and then we'll go on to ways of how to interpret the results, what do we need to look at, what are things to watch out, what are limitations when interpreting results, and then we'll discuss briefly what are the benefits and the limitations of LCAs, and what should we consider when looking at the results and when conducting this type of research. And finally, we'll have a small case study where we basically apply everything we've learned and we discuss any questions that might arise, because I think having a practical approach then oftentimes helps you come up with the questions, because there's so many little things that when you hear the concepts, it makes sense, but then when you start doing it, you get a lot more questions, and I think is way better way to solidify what we've learned over the session. So I'll start by explaining what a life cycle assessment is. Life cycle assessment is a type of environmental impact assessment. Environmental impact assessment can be done with a variety of methodologies, but life cycle assessment is the data-driven version of that. So a life cycle assessment in itself is a compilation, evaluation, and evaluation of inputs, outputs, and the potential environmental impacts of a product system throughout its life cycle. A product system could be one singular product, or it could be a system such as a waste management system. Just keep that in mind. Obviously, the more complex the system, the larger the life cycle of the project is, but it is always a very similar approach. And then life cycle assessment specifically establishes the environmental impact of a product, a service, a system across its whole life cycle, or in some cases you can decide to only look at certain stages. But usually if you're you usually do the whole life cycle to better understand where to focus on, what are the parts with the largest environmental impact. And the stages that that comprise a life cycle can be raw material extraction and acquisition, energy and material production, manufacturing, and then also on top of that, the use of the product itself or the service, as well as the end-of-life treatment and final disposal. Although in each section you're acquiring new materials or using energy or some other sort of resource to make changes, and in each section there'll probably be some waste. We will not be focusing that, but it's also important to understand that each stage has transformation and has inputs and outputs. So we're not just thinking that inputs come at the beginning and outputs are at the waste disposal. Now, now we have a very quick overview of what an LCA is. What are some considerations that we need in order to achieve a good life cycle assessment? What do we need to think about when conducting the life cycle assessment throughout the entire process? First of all, and I think this is the most essential, is that we need comprehensive and reliable data. The more data, obviously, that is pertinent to our life cycle assessment that we have, the more precise and more accurate the results are going to be. But besides being comprehensive, it has to be from reliable data sources. That could be primary or secondary, but we always need to try to understand where the data is coming from, how it suits if it suits the needs of our life cycle assessment, and we need to keep it and we need to present it in a transparent form so that it can be peer reviewed. And so when we look back on it or we do several other iterations, that we can look back on our work and make sure that we've done that we can sense check what we've done in the past and that we can build upon that in a way that is transparent and thought out. And all of this then comes in together into a life cycle inventory, which I will explain in more detail. So we need to have, but before we get into life cycle inventory, before we start, we need to have a good methodology that is robust, well thought out, includes all the data, all the things we want to cover, a system boundary that is clear, and then all the data is clearly presented in a life cycle inventory. I'll explain this terminology later on, but for now, this is what I want to touch upon. Then, what are the limitations of the LCA that we need to consider before we start? Is that the results are static. What do I mean by this? The results are sort of like a photograph. They're in one precise moment in time and in circumstances. Reality is a bit more different. There's a bit more variation in, let's say, the amount of electricity you use to heat up a meal. It's not always the same amount of heat. So that is what we mean by static. There are always limited. We cannot always get the most real-time precise data, but it's good to give an overview and to give us an understanding of the life cycle of any product or system. Or another thing is when we are looking at the sustainable development goals, which are obviously the center a lot of the environmental and sustainable work that is done across all centers and all forms of research. Life cycle assessment is useful, but it cannot cover all types of development goals. But it's very good at covering the ones that can be quantified, such as greenhouse gas emissions, production of hazardous waste, use of fossil fuel use and other limited resources such as minerals, marine pollution, ocean acidification, and land use. These are all things that are quantifiable. So other things such as social aspects are a bit more difficult, but so it cannot be used by itself in these cases. But it can be a good addition to your current research. So let's start. When we're thinking of a life cycle assessment, we first need to think of what the goal, what is the intended application, what question do we want to answer with our life cycle assessment. Some examples can be to compare two different products or services that are similar or can be used in the same instance, or just within one product to see what is the stage of its life cycle, whether that's production or disposal, that is having the highest environmental impact, so that we can focus on what are the main drivers of this environmental impact and find alternatives to reduce it or to contain it, and to see what can be done, what can be changed. And then also to understand what the exact effects on the environment are. We know that certain treatment facilities, such as waste disposal, landfills, can have a negative impact on the environment if they're not done properly. But is it air pollution? Is it land pollution? We need to know exactly how does it affect the environment, so that then we can have more tailored solutions and we can understand what the effects are not only on the environment but on the population. Let's say, for example, plastic burning in Indonesia, you would focus on air pollution because when you burn plastic, it is released into the atmosphere, and there's a large concern in the area for respiratory disease related to air pollution. So here's where you need to think at what are you looking to study, what is the interest of your study. Then we need to come up with a functional unit. What I mean by functional unit is when looking at a product, are we going to look at the entire life cycle? Or, for example, when we're comparing two products, let's say an organic tomato and a non-organic tomato, are we going to compare per one tomato or per 1 kilogram of tomatoes? Which is the most fair unit to make a comparison or to understand the environmental impact? Also, selecting the functional unit is very important, especially in the case of comparison, because if the products have different sizes or different scales, you want to be penalizing behavior and not necessarily scale and things like this. So let's say in the case, going back to the case of organic and non-organic tomatoes, maybe the best solution is to do 1 ton of organic, 1 ton of non-organic, so that then you can see what pesticides have the most impact or how much land is used per production of ton of tomato and such things. And then the scope, I think this is oftentimes the trickiest because there's a lot of things to consider, and it can be difficult in the beginning to select the right scope for you. But the scope is the boundaries and the method of the product we're studying or the system we're studying. It means the geographical location. Are we looking at one region in specific, or are we just looking at the general process? Because let's say production of tomatoes in Europe versus Asia in low middle income countries, or even in South America, North America, can vary drastically because of the resources available and because of standards for fertilizers and so on. So we need to be very clear about where we are trying to source our data from and at what region are we looking. And it is important to be very clear about this so that then when we interpret, we are aware of this. Identifying the main products. So the product is what we're going to be focusing. The co-products are, I will explain later on, and byproducts that may occur, as well as the data sources that we're going to be using throughout to collect the data for the life cycle inventory. We need to make sure that it is either primary data, and in the cases where primary data is difficult to find, for example, you don't know the exact fertilizer that you're using for cultivation, you need to find ways about it, looking at national statistics, regional statistics if possible, the more precise the better, but if that is not possible, finding other ways and being clear about what were the limitations of the data and how did you cover them. In the case of secondary data, there's oftentimes national databases, although it is true that in low middle income countries and it is more difficult to find precise data, especially in the life cycle assessment specific databases. So that is a limitation that we oftentimes encounter in life cycle assessment, but there are ways to work about it, and we'll discuss them later on. So now we're going to be looking into we're going to look at some of the visual aspect of it. So here you can see on the left how it is not just linear, the goal, scope, inventory analysis, and impact assessment. There is a back and forth. The reason for that is because oftentimes we have to revisit our own goal and scope, our inventory, our impact assessment, because it is such a large process. There's so many little things to look at throughout the process that we need to look at what makes sense. And the direct and most important, and I think the most relevant applications for us are product development and improvement. But in this case, what we mean as interventions, selecting certain products or services over others and justifying why based on data that we have collected. Planning strategically, so seeing what are current weak links in, let's say, a distribution system or in a service that we provide that can be provided, whether that's public health service or food service or water treatment service, and then using this information for public policy, for public awareness, to make people understand that, for example, certain measures of waste disposal, such as plastic burning, can have serious effects on health. And then to be able to market our interpretation and the results we've gotten, and to explain not only to the public but also to policymakers so that we can have the most impact with our research. And then here you have the stages of a life cycle assessment. We've already covered the goal and scope. And now we'll go on to the inventory, which is where we get together all the data and the impact assessment, and then we'll finish with the interpretation. But before that, I want to clarify something that I've already mentioned, which is products, co-products and byproducts. and waste, what the differences are, and a term that comes up a lot in life cycle assessment that is called allocation. Product is the result of a process. It is what you are focused on. So if you are looking at, let's say, rice, at production of rice, you're only looking at rice, but there's other co-products. So that can be rice husk, that can be straw. These are co-products of which you can profit, you can sell, or you can input into a different product or system. So in that case, a straw can be used as animal feed, husk can be used in other processes for food. So this is where they're called co-products. And then byproducts is similar products that come from the same process. So from the treatment of rice, you get let's say dust, or other products that have no income value, that we cannot reuse and gain economic or any sort of use that is particularly interesting. But that their removal can be useful for us. Let's say in some cases, straw cannot be sold, but but a farmer can use it for feed, but they are not giving money. Then in this case, it'd be more considered a byproduct, not a co-product. But both products have a certain use, or can be used in a different way. In the case of waste, this has no value, it actually has negative value. We need to dispose of it in a way that is responsible, and it cannot undergo much more processing besides waste disposal, maybe recycling, but that is not the main purpose of the outcome of this outcome. So in this case, it will become waste. This will happen in any unit process. So this can be in raw material acquisition. This can happen in treatments, in material production. So we're inputting goods from the processing and the resources, which is energy or fossil fuels, for example. And in this process, there's waste generated, which we cannot use, we dispose of, emissions, which we will later on measure in the results. And if there's several products, product is what we look at. Co-product is the other products that are resulting from this that have value, and byproducts have lesser value or almost no value. And allocation is the way you divide, since there are several products and co-products from the same process, allocation is how you divide the emissions from the same process. So you usually can do that either by weight. So let's say from rice processing, half of it is rice, half of it is straw. This is not realistic, but just to simplify. Then half of the emissions would pertain to the rice and half would pertain to the straw. And this is in order to not penalize further than necessary. And because by using the straw for something else, you're actually you're avoiding emissions in this process. Whereas if you dispose of it incorrectly, then that can be considered waste and that can be additional emissions. So it is something that needs to be well thought out before you start the life cycle assessment, because it can change your results and it always needs to be justified and make sense and backed by your methodology. Now we're gonna look at the scope. There's a lot of terminology that is not very commonly known. We use it for life cycle assessment. When you're looking at the entire life, it's cradle to grave. And if it's only up to a certain point, as you can see here, from extraction to the end of material and part production, then will be cradle to gate. If it is just a specific unit process, then it's called gate to gate. Gate is when it is taken out of the process of the unit process or the location and transported onto the next. Also, it is important to keep in mind that oftentimes these arrows, they refer not only to a change in unit process, but also to transport. Sometimes the facilities are nearby, sometimes you need to transport, and this is another factor that you always need to consider when collecting the data. So now that we've thought of what the goal is, what the function units that we need to consider and makes the most sense for our research, What is the scope? What are the parts of the life cycle that we want to observe? Where we're going to get the data from, if it's going to be primary, secondary, what our databases are going to be, and what is it that we want to, what type of impacts we want to consider. Now we have all the raw data we've extracted, hopefully. Now we're going to move into developing the life cycle inventory. Life cycle inventory is a very detailed list containing all the inputs and outputs that will be making up your life cycle assessment. And this data has usually been already processed to fit the functional unit as well as the goal and the scope. This looks, I know this looks a bit haunting, but it is quite extensive because there's a lot of information that you want to keep track of in order to then be able to revisit and do further iterations of your life cycle assessment while maintaining transparency and stay on top of the data, understanding where your data comes from, how you've evaluated it, what the point of this data is. There are many ways to do this. You can find a method that works for you, but this is the one that I found that works the most and is the most complete. So what I usually do is I divide the life cycle inventory by stage, by unit process. So that could be raw data, raw material acquisition, and then separately having the processing of said raw materials. And this way you have clear division. You understand when one process begins, the other one ends. And in each line, you will have the product and the activity. So let's say the product is electricity and the activity is the production of electricity. That could be through a specific version or through the electricity mix of the country. This is usually present in life cycle assessment databases. Here, it is also very important to have locations. In this case, I've just put Bangladesh as an example. As I said, in low middle income countries, it is oftentimes difficult to find exact data to the country, but there is data that is for rest of the world, which is the term that they use for non-Western countries, because in Western countries, that's where there's the most data, especially in the databases. There's a lot of data from France and from Switzerland because they're the companies that collect the databases are usually based there. But there's also global data. Is this less precise than, let's say, having Bangladesh specific data? Yes. Is it more precise than using France data? Because it is at least a more conservative approach, a more general estimate. So it accounts for less specialized equipment or for different types of transport. So it is a better look at it. It is also important to keep track of what database you're using. If it's a specific life cycle assessment database, if it's a ministry database, because oftentimes, for example, in the UK, we have DEFRA for Environment and Food and Rural Affairs. We have data from them. So we want to know where we got it from. Or if it's from primary data we've collected ourselves, we need to know where did we get it from exactly, so that we can refer and check. Input is things that enter the process, so that can be electricity, raw materials, or a product that we want to transform. Output is the resulting from the unit process, so that could be product, co-product, byproduct. But here is where we need to be careful and make sure that this is specified in the comments, although we will know, but we need to make it in a way that anyone that understands life cycle assessment can look at our life cycle inventory and can see our thought process, how we got this data, where it's from, what the values are, what the units are. This is quite useful always when inputting the data into softwares, because softwares don't always have the exact same units for the same product in similar databases. So you want to be careful about that. And then uncertainty, especially in primary data. If you have collected, let's say, the water you need to water a plant or an acre of land, there might be discrepancies due to farmer preference or many other factors. You need to account for the variations in the data. So in the input, you would use the average And then in the uncertainty, you would use the standard deviation. This will be useful later on because you can do a Monte Carlo simulation, or you can do an uncertainty analysis in which you can see what is the range of results you can get with this standard deviation. But these are all things that we are not going to cover in detail today, but I want to get them out there so you can start thinking about this when you are looking at data, so you can think at what you want to do, what you want to get out of your data, what you should be looking at, how you should be grouping the data that you have, and how exactly to arrange it so that then it is most easiest for you to transfer it to the life cycle assessment software. Because that is in my in my opinion, especially when you're going from primary raw data, having a good LCI is the most important step to make your life cycle assessment, making the simulation easier for you to follow, and then also for sense checking what you have done. That is going to be most important. Then impact indicators. Once you've done your life cycle assessment, your life cycle LCI, you've gone on to do your LCA. You need to look at what are the exact values of environmental effect scores that you want to look. There are a variety of suites of environmental impact groups, and the one I usually use is recipe. Also, it is important to note that there's midpoint and endpoint indicators. Endpoint are the most general. It is when you want to have a good idea. And there's usually three types of endpoints. So damage to human health, damage to ecosystems, and resource scarcity. But so that is good if you want a quick overview. But in majority of cases, we're looking at something in particular. There's an environmental problem that we want to see and that is most interesting to us. So in this case, we usually use midpoints. And I think this actually is much better because it's where each impact category is looking at a different environmental problem. So, for example, climate change refers to greenhouse gas emissions. That is one that we use a lot when looking at environmental impact, but also let's say in cultivation, land use is very important, as well as soil toxicity. So we want to pick the environmental impacts that are most pertinent to our objective and to our situation. Because and the way these impacts are calculated, they are calculated by the software. So don't panic, you will not have to do this from scratch. It looks at all the associated emissions. So that can be NOx, cadmium, CO2, methane, other sorts of emissions, and it groups them by the sort of effect that they might have. So in the case of greenhouse gases, CO2, carbon monoxide, methane, so on. I'll group them and I'll give you the result for climate change, which in this case is global warming potential or greenhouse gas emissions. And then from there, you can interpret these results and you can see what you want to extract. So as I said, I usually use recipe suite, but there are a lot of others that are also valid, such as the IPCC, the ECO one. This is where you need to do your research and see what makes most sense for you. But just they are quite similar in the sense of the environmental impacts that they cover. In this case, as I said, we have global warming potential, and in parentheses, you can see the sort of what the units are. In global warming potential, you can see CO2 equivalent. That is another thing to note, that when it's grouping several types of emissions, it will do the conversion of, let's say, methane into CO2 equivalent and things like this. That doesn't mean that the methane is no longer accounted for. It just means it's been made to fit the unit, but it is still present. But it is also important to note that global warming potential can be for different time frames. So we usually use for 100 years, but it can be for 50, 20 years. But this value changes. Why? Because not all gases stay for the same amount of time. They have different lives. And I'm just talking about global warming potential at the moment, but this applies to all the other categories in more or in a higher or lower degree. But we need to think about all of these things. You need to select your impact indicator carefully, because you also don't want to overwhelm the reader if you're doing this for a publication, or when you're making a decision, you want to do it based on the most suitable ones, but also be aware of all of them. A good resource for this is, I think it was previously sent out, is the Huysbrecht's paper. It goes into detail into every impact indicator. It tells you the reasoning behind it, tells you the endpoints and how it comes to calculate that. So I would recommend that you read that to start out. And if you want to look at other environmental impact indicator suites, that is also a great idea, but try to read about it and choose the one that makes the most sense to you. In life cycle assessment, as long as there's a logic and there's a clear methodology that can be defensible and that is peer reviewed, you have the freedom to make your choices based on what your interests and what your objectives are. And it is important that you do something that works for you and that is tailored to the specific problem, because it is such a broad tool that it is very difficult to just say these are the steps you need to follow. There's a general steps, but there might be large variations in how you collect data, how you treat data, what impact indicators you use, and it is important to think this all through before you actually get started, so that then you know how to keep track and you know what to look out for. Another thing that is entirely up to you is the software. A lot of the softwares are you need to pay for, but you don't even need to use a specific software. You can, if you have the data, if you have the associated emissions with each product, you can even do it on Excel. Especially if you're looking to use this down the line with people who are not specialized in LCA and that don't have access to LCA softwares, Excel is oftentimes the best option, so that you don't have issues with licensing, so that you can use it. The curve in learning how to use it is much easier to assimilate. But if you want to continue to do this continuously, you want to become an expert, there are specialized softwares. I most commonly use Activity Browser. The Activity Browser itself is open source and allows for reproducibility, but certain databases for impact categories, such as the EcoInvent, you need to pay for, but Biosphere and other ones are available. So it is up to you and what you want to do, what your resources are. Another one that is free is OpenLCA. It's up to your preference. I just find that Activity Browser is a bit less clunky. And then I'm also going to mention some specialized software that LCA practitioners use quite a lot and that are quite common in the industry, which are CIMAPRO and Gabi. None are better than others. There's no ideal software. It is up to you and your needs and your knowledge and what you feel most comfortable in and what the application is. Here I have some screenshots of what the Activity Browser looks like. On the left-hand side, you have the databases. On the right-hand side, you can make up your own systems, products, and then in the bottom left corner, you can see the visualization of all the different inputs, the product itself, and the output. Do the softwares change? Yes, there's some learning curves when you switch from one software to the other, but they're quite similar because they have the same purpose. It's just about getting comfortable with them. But once you've learned one, you can figure out all the other ones quite quickly. And there's usually a lot of data available online on how to improve their use. So it is not a limiting factor. Yeah, as I said, it's up to you. So Excel and Activity Browser are both open source, OpenLCA as well. And then if you want to go on to Gabi and Cima Pro, I think there's also trials if that's something you're interested in. Now that we've discussed everything that leads up to the results. So we've gone over goal and scope definition, data collection, lifecycle inventory, and how to develop it in a way that is useful. Then all impact indicators, the software. Before we go on to the result, I need to highlight that this is an iterative process, meaning that you can collect all the data, do it for the first time, and rely and check your results and see the results are not making sense for some reason. I'm not getting what I would expect, what I've seen in similar literature. Why is this? You will have to review all your data. You'll have to go over the simulations themselves because oftentimes it's just human error of inputting making the simulations not in the way you want to. So you will have to do this a few times, and I especially recommend in this case discussing this with a colleague so that because having a fresh pair of eyes helps you consider things that you might have missed before. For example, there's a lot of water that you can choose in the databases, rainwater, from the treatment plant. You might have not chosen the right one, the right product. You might have put in the wrong amount. You might not have considered the uncertainty correctly. You might have put it as an input when it's an output or a co-product or waste. These are all things to consider, or maybe you just haven't used the most appropriate environmental indicators. So these are all things you'll have to check, you'll have to go over, you'll have to think through, and it'll take you a few tries. That is completely normal. And I think that actually proves that your methodology is being questioned, it's being revised, it's well thought out. Once you get the final results or even preliminary results, it is important to understand because it's just where do they come from? We have the numbers, we have all the products that we want to compare, but we don't know what it means. So here I have the climate change of a few products. As you can see, we just have the general results on the top part. So this is just the total results. Here we need to check, has the functional unit been appropriate? Are we comparing lemons and pears, or are we comparing the same thing? Let's say we're comparing water treatment technologies, ponds and filter, traditional water treatment plants, desalination plants. The scale of each facility is very different, so you cannot do it by facility. You must do it by the same amount of water treated. Let's say 1 liter, 1 cubic meter. That will not play a large role because we want to see which one has the highest emissions. But if we penalize just the larger scale factories, then that does not make sense always. Oftentimes they tend to have lower emissions because of the larger scale. So once we've made sure that our results make sense, that they're correct, we need to summarize our findings, which are the general results, and address what the assumptions were, the boundaries, and what the sensitivities are, as well as what can be weak spots in our data. This is always important so that if someone takes our data, they know what can they change to make it a higher quality. And then also other things that you can interpret in the findings is what makes up these results, what are the biggest contributors. Once you have all of this summarized and you've thought it through and you've checked that is properly done, that there are no issues with your methodology, you can then go on to do a critical review, go on to the discussion of your manuscript, for example. In this case, what can you do in a critical review? You can compare your assertions and disclose them to the public and see if they fit with the standardized procedure. You can compare, as I said, different products. You can also add confidence to your findings, especially if it's for example, if it's in a region that doesn't have data in the life cycle assessment inventories that are on databases that are already existing. You get primary data and you do your LCA based on this. That's going to add confidence to your findings because it is accurate data of the situation, of the context, and you can confirm the transparency and the completeness of results. Here's where you say what the limitations of your data collection were, for example, what are things that are not directly considered, and other things that may have occurred throughout the process. So what you can do, in short, what you can do with results, look at the total results of several products to see which is the best choice and compare and see why are they so different. Look at one set of results. Well, you can see on the bottom that there's sort of a Sankey diagram. You can see what the main contributors are by percentage. For example, electricity. If electricity is derived from a coal power plant versus a solar panel power plant, the results are going to change drastically, especially if it's an energy intensive process. So here is where you can see main emissions are from electricity. How can I change this or any other part of the process? That's another very valid way of looking at the data, and this is called hotspot analysis. This is especially useful when you're looking at a system or when you're looking at the whole life cycle of one product to see where your failures are in the product. For example, as we mentioned in one previous example, tomato cultivation, maybe using biofertilizers will yield better results than using traditional fertilizers and synthetic fertilizers. So these are all things that you can swap out. You can see how this affects results. And this is another great point to discuss with your LCA that is based on data, and that then you can have applications that are of interest to you, such as finding new strategies, optimizing existing systems, coming up with legislation to improve standards, let's say, for operation procedures and so on. This is all things that you can interpret your data and then findings you can have from interpreting your results. Then, we've briefly touched about the benefits and limitations. We're going to revisit now that we have all the procedure in mind, that we know what all the steps are, what are the considerations. The benefits are that it can be great for regulatory and legislative because it's based on data. That is oftentimes a good way to support your proposition, and in a way that is not subjective, but that is objective based on the data. And then you can promote a product and declare its benefits or not. This is also common in a lot of the product quality assurance, and it is oftentimes a legal necessity for companies to do. Comparing with existing benchmarks, for example, the maximum emission you can have from electricity, let's say it's 300 grams of CO2 per kilowatt hour. Are we in line with the benchmarks or not? Why are we meeting them? Why are we not meeting them? How can we improve to meet the benchmark? These are also other ways of using life cycle assessment to understand. The results is that they are based on data and that there's a defensible methodology that is well defined as per all the previous steps. Having a clear goal, a clear scope, functional unit that suits your project, having collected the data from primary, secondary data, putting it into a life cycle inventory in a way that is complete and transparent, having selected the appropriate and explained why you chose the environmental impact indicators, having processed the data and gotten results based on this entire methodology that we've been going over. So you can defend it, you can say step by step. If anyone has any questions, they can look at your entire process and they can see that there is a clear methodology, a clear process that's been checked and sense checked by other people and hopefully peer reviewed. But what are the limitations? Boundaries oftentimes may exclude important factors because of lack of data. You've decided not to look at the extraction of the production of ammonia for fertilizer. Ammonia is a high resource product that can have of which the production can have a lot of emissions. But because you're only looking at the tomato cultivation, it might not be the most important thing for you to look at. This is important always to acknowledge these parts that we are not considering. But it is very easy to go overboard with the boundaries. We need to find a middle ground. But it is always important to acknowledge what we might have missed out on. As I've probably mentioned several times, there is oftentimes lack of data, especially in low middle income regions, or even in regions that have much less bookkeeping or formal methods, or even certain types of work such as husbandry or poultry production. It is oftentimes very difficult to get precise data because nobody's going to be writing down exactly. So it is important to collect data in these cases. And then the methodological choices we've made might be useful to us and to our project, but when someone else looks at them, they don't understand them, they don't make sense to them. That is fine, as long as our selections make sense for us. We've explained what our objective is and why this suits our objectives. Some environmental impacts are much more difficult to quantify just because measurements are very time consuming and very resource intensive. So that's why we use life cycle assessment and we don't measure ourselves the emissions in each and every single case. And also, as we were saying, that it's static, it's kind of a snapshot. It is limited to a certain time and a certain location. So if the data changes, if the situation changes, then our results could change, but it is still worth doing and comparing. And oftentimes, hopefully not in our case, when we will do life cycle assessment, there is a lack of transparency, but oftentimes this happens, especially with some tools such as Farm, if you want to look into that. It's very, very gray in the sense they don't explain what their emission factors are, their methodology. So this is also something that is important. If you find a new tool, it's important for you to be critical of that tool and to understand if it's suitable, because if there's a lot of things you cannot explain how the tool works, then that falls upon you as a methodological weakness, and you want to be able to defend your entire methodology. So you need to be careful with what tool you use. Am I saying not use these tools? Absolutely not. That's up to you. Or you can even test them, you can compare them. But this is something that you should definitely consider and be very careful. Limitations, there are limitations, but as long as you explain them and you try to mitigate them as much as possible, I think you can have a very successful life cycle assessment. And I think that having not the most, maybe being a bit off in the results over not doing any sort of environmental impact assessment is beneficial. It's a learning curve, of course, but I think it can have a lot of benefits and it can support existing research that you all must be working on at the moment. And I think it will add further value. We'll get started then with the case study. There will be a Mentimeter just to make it a bit easier for us all to interact. But I'll start by giving a brief overview. And if you have any questions or you want to discuss something on what your thoughts are on the case study, you're also very welcome to do that. So we're going to start with looking at 2 simple meals that are provided to primary school students. And we want to understand what the environmental impact is, because we want to know which meal is not only is maybe in our research, we're looking at what meal is healthier, but we also want to know which one is more sustainable. So the meal one is tomato, potato, and tofu. Meal two is tomato, potato, and beef. So what is going to be the goal and the scope of of our of our life cycle assessment? Are we going to be looking at the cultivation? Are we going to be looking at the cooking, disposal of waste? What do you think? I'm gonna share the Mentimeter so you can. Can you see the Mentimeter?
Yes, yes, we can.
Okay. Then either feel free to speak up or just add it into the into the Mentimeter. Oh, sorry.
Alexandra, can you, yeah.
Yeah. Yes, cultivation. So in cultivation, we'd be looking at water consumption, land use for cultivating the products such as tomato and potato, or the soy, um, pesticides, fertilizers, the energy from machinery that you might be using. You can also see how much people you have to select. The goal is to select which is better, beef or tofu. Yes, but I think mostly which meal. I've made the meals very simple, but which meal is the most has the better environmental impact. So the objective would be to select the best meal and the stages that we would be consider. And what are the stages that we consider are cultivation, transport, and preparation, or would we just be looking at one or two of these? Mhm. And for example, in the case of transport, would you be looking at the transport of, let's say, the fertilizer to the cultivation site, the farmers bringing in the fertilizers, or would you exclude that from your boundary? Would you look at the transport between the farmers and the schools, let's say? There's no middleman in our case. And the preparation, what would be looking at? The products, any other products that you might have used to prepare oils, spices, the energy, if you're using gas, you're using firewood, electricity, all of these things that you might consider. So, in my opinion, in this case, since we're looking at the meal is not only the products and where they come from, there's also how do they get to the school where we're going to be preparing the food. And also, although it is not included here, what happens to the waste? Is there waste? Is it just, thrown away, disposed of, or maybe they can compost the organic waste and reuse it for having a garden in the school grounds, having other uses. This is also other things that we can consider. There's not, in this case, there's not a one right answer because we don't have enough information as well. So this is also, it's okay if you have different opinions. And now, what would be a suitable functional unit to attain our goal? Our goal is to compare both meals to understand which one has a lesser environmental impact. So based on this information, how would you compare, what functional unit would you use? Per one meal or per several meals? Any other suggestions? Tomato per gram? Then you would have to separate by product, but you're looking at the whole meal. So tomato, it might be earlier on when you're looking at the cultivation, you'll be looking at the emissions in 1 kilogram or 1 gram of tomato, although gram is quite a small unit. In this case, could be used, but then you wouldn't be getting the whole picture. So per meal, I think would make the most sense. Although per meal is broken down to, let's say, 50 grams of tomato, 50 grams of potato, 50 grams of beef or tofu in this case, just to keep it easy. So I think per meal is probably the most sensible one. What's another unit that maybe we can use, because we're looking at a school, for example, of all the meals generated in that day inside the school. That could be another unit. If we're not looking at the specific meal of each person, we're looking at the emissions of the school. That's another method. Or let's say throughout a week, there's different meals. So you cannot compare the meal of Monday and Tuesday, because obviously the one that has lesser protein, lesser animal products is going to have lower emissions most of the time. But you also don't want the trade-off of lower nutrition. So in a way to avoid that, you could do all the meals per student in a week. That's another functional unit that could work if your objective is to reduce emissions in the school, while also allowing for variety within the meals to get a complete nutritional, a good nutritional plan. That's another option. What what is information that you feel would help you to make better choices, to better understand what is data that you would collect in order to obtain the results that you want? There's a lot of answers here, so there's a lot of information missing. So I want to hear what you think is what you are interested in finding out. Yes, data. Or do you mean like exact numbers data, or do you mean a specific for one specific thing? You can be a bit more exact with what sort of information you want. Life cycle inventory is the end result of your data collection. But yeah, you need more data for your life cycle inventory. But what is the specific data that you need? Quantity of tomatoes, yes. The quantity of the ingredients in general. What are other things that we need to consider? Because we're not just considering cultivation in this case. We're considering the cultivation, the transport, yes, per gram of beef, and transport distance. What are other things that we need to know besides the transport distance? Like there are many types of transport. Amount of all ingredients, correct. Mode of transport, yes. Yes. Also vehicle information, because the standards for emissions for vehicles change drastically per country. Impact categories. Yes, we need to know what interests us. In this case, it could be, for example, global warming potential. That would be a good one, just to get a quick overview of the impact on the environment. Fertilizers, water use of each meal, because if you would need, for example, a lot more water to raise beef or any other animal than you would to cultivate the soy for tofu production, because beef and ruminant animals actually have some of the highest environmental impact. We've covered some data regarding heat use. Very good. That is a very good one. So, how are we cooking the products? What is the difference between, let's say, firewood, gas, fuel oil, so on. Also, what are other things? Maybe you boil the food. That is different from frying. That's something else to consider, so on. So as you can, this is just a few things, but we could go on for hours about all the information we need. Also, what is the location of the farm? The amount of land used to cultivate, the amount of tomato necessary. Yes. Yeah, just we could go on and on. This, if I'm gonna give you a bit more information because it's very difficult. Let's say that we are looking primary, yes. But what if if you cannot get all the primary data? What if you cannot get access to all of it? What if you are not on the site? In this case, primary is preferable, especially if it's in the case where I was gonna say it is in a location in rural India where there has not been prior research, there's not a lot of information on the databases, you'd use primary data. But what if it were in Europe? What if it were in, let's say, France, where there's already a lot of data? There's specialized databases just for France and for food production. Would this change your answer? Still prefer primary data. You also have to think what are the resources available to your research. Maybe in the case of France, secondary data is actually more useful because it is quicker. You can just use national data if there's no very specific site, or if it's a farm with which you have contacted and they have given you the amounts of water, fertilizers, and so on, and you have the databases to combine it, then you are set. In majority of cases, I want to make it clear, majority of cases, you will need to use a combination of both. Because you're not gonna, because for data such as the amounts of inputs and outputs, that is much more easier to ask. But what is the amount of CO2 generated from burning polyethylene? Is very different, can differ from a different type of plastic. You're not going to go and measure every one of these. So this sort of information of what the actual emissions are, that is usually most of the time from databases. So even though you're collecting primary data, you will always have to use most of the time you will have to use secondary data because it is a very resource and very time intensive process, and it is not, unless you have specialized equipment, it's not possible. So these are all things to consider. Primary data is great. Secondary data is also very useful. Of course, oftentimes there will be some caveats to the data you use and if it's the most appropriate, but it can be very useful in most cases, especially when you don't have access to the site. And in this case, what do you think are impact categories that are suitable? So global warming potential, land use, water consumption, terrestrial acidification, ecotoxicity. Ecotoxicity is the deposit of pollution that is detrimental to water health. There's difference between marine and fresh water, just for your information, and also for terrestrial health. Ozone depletion. There's also impact on health, carcinogenic and non-carcinogenic. I'm just listing them for you to decide on which ones you think are most useful. yes, global warming potential. It's always good to give you an overview. But in this process, land use for cultivation or for, in this case, the raising of the cattle, other impact categories, water use, correct? If you cannot use the Mentimeter, please type in the chat or just speak up. You're very welcome to participate. Land type. There's no specific to that, to land type. Maybe what you mean is effects like land pollution, such as acidification, ecotoxicity, maybe that. Although the impacts on the type of land you're using also could have an effect. Maybe the use of fuel oil, fertilizer and pesticides. This is usually would be in acidification or soil pollution, terrestrial acidification. It is not measured by itself. Resource depletion, this could entail not only fuel oil, but also could refer to minerals or even water is a finite resource in the cases of LCA that can also be considered. So there's quite a lot here. Yeah, this is a good. Has the new information that we've discussed, would it be helpful? The other information I've given you, such as the amounts, do you think that this is enough, or you need more information? Yes. The more information, the better. Yes, I agree. But yeah, but today was just a quick overview, just so we can start getting into the way of thinking of making a life cycle assessment. In the next presentation, we'll have a much more detailed case study. I think that will be much better and more useful. We will have I will send you previously before we get started some information so you can start thinking, and then we will go over it and do it together and look at how you actually go about making a life cycle inventory, conducting a life cycle assessment, and then we can all together interpret the results, come to our own conclusions, maybe have to get into two groups and argue different options. So I think that would be great. Yes, and this is the end of the Mentimeter. Here are some resources, and I hope that this was useful. If you have any feedback or any questions, yes, please do not hesitate to get in touch.